Alright folks, so today we're going to talk about some topics that compose the idea of central tendency, namely the mean, median, and mode of a data set. So we're kind of checking off a bunch of boxes in the world of descriptive statistics. We'd mentioned that one way to describe a data set is to discuss its shape. And in a previous video, we looked at various distribution shapes. But another really useful descriptor of a data set is where is it centered? What might be its average? And then we will shortly, maybe next week, discuss its spread. So we've already done shape. Today we're going to do center, and shortly we'll do spread. Let's start with the average. We usually call it the mean in stats, but you probably know it as the average. And we'll do an example, but we often have a shorthand for it because we use it so much. One of the ways that we denote the average is usually with y with a bar or x with a bar. That's probably the most common. If you had another variable name like weight, you might use a w, but more generically, x bar or y bar are very common. Let's dive into this example. What I've got here is a sample of size 7, and these are 7 ages that I've gathered from a previous class. So I'm going to list these here, and here I go. 17, 18, 18, 19, 20, 21, and 24. 1, 2, 3, 4, 5, 6, 7. Got them. All right, we're going to get the average, but I'll also use the notation. If we're going to compute the average, I'll call it y bar, and we're going to add up all of these values. So 17 plus 18 twice, plus 19, plus 20, 21, and 24. Now that's not it. Remember, you have to divide by the sample size. So here, that would be a 7. I've got out my handy dandy calculator here, and I added up all the 7 ages, and now I shall divide 137 by 7 to get an estimate for the average age. Y bar is approximately 19.5714 years. Moving right along, let's move on to talking about the median of a data set. The sample median, you might see medians like in the highway or freeway, right? It separates the two halves of the highway. Well, that's kind of what's going on with in statistics. The median value, it's the value that is in the middle of the data set when the data are in ascending order. So they've got to be in order first, because if they're not in order, then finding the value that's in the middle is just an arbitrary value. Well, let's go ahead and do an example with the ages from just a moment ago. I'm going to copy and paste those. Okay, I've copy pasted the 7 ages from just a moment ago, and I already wrote them in order, so that's really nice. They're going from smallest to largest. And I want to identify the value in the middle. There's 2 ways to do this. I'm going to show you the way I kind of like it. I'm going to call this the naive method. But this is when you sort of inch along, smallest to largest, until you reach the center. For us, that would be this 19. So the sample median is 19 years. Because this is a small data set, that's not too difficult to accomplish. But if there was hundreds of values, well, we'd want to get the help from a computer or calculator, but we could also still get the job done with lots of values, and I'm going to show you how to do that with a formula. Let's look at a formula. To get the median, we want to find the value in the middle. So the formula for this, it's kind of an interesting formula. To chop something in half, you take the total number that there are plus 1 and then divide that whole thing in half. So this also, I'm writing TH right here because we want to identify the value in the middle, which in this case it's going to be the fourth value. This 19 was the 1, 2, 3, fourth value. So that's what that TH is representing. It could also be the 14th value or 61st value. So I'm going to write value there. Let's work this out with our example. Median. We know that there was 7 values, so that's n, plus 1 over 2. I'm going to write th value. We know 7 plus 1 is an 8. 8 over 2 is a 4. Now the answer is not 4. The answer corresponds to the fourth value when arranged in order. As mentioned, 1, 2, 3, 4. The fourth value corresponds to 19 years, and we are happy as clams. Now that worked out really nice because our sample had an odd number of observations. We had sample size of 7. And it just is a little bit more tricky, just mildly so, when you have an even number in your sample. So over here, I'm going to do this again, but with an even sample size. I'm going to take our 7 ages from a moment ago and just tack on another age. Maybe say my age. I think I'm pushing 35, but I've had 34 birthdays. So now 1, 2, 3, 4, 5, 6, 7, 8. We've got a sample of size 8. Let's find the median. Same sort of process as earlier. I'm going to use the naive method at first, where I'm kind of looking at the smallest to largest, boop, 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 until I reach the center. And in this case, I do not land on a value. It was sort of a tie between the 19 and the 20. So in this case, our median will be the average of the tied values. In this case, 8, 19, and 20, therefore our median will be 19 and a half, 19.5 years. If we use the formula approach to calculate this median, we are going to take 8 plus 1, chop it in half, and then what value does that correspond to? Okay, so that would be 9 chopped in half. That's 4.5 value. And it works in the same way as earlier. This is a tie between the fourth and fifth value. So it is not the fourth, not the fifth. It is the average between the fourth and fifth value. So I'm going to highlight this again. So the fourth value is that 19, the fifth value is that 20, therefore 19.5 years. All right, I've got a couple questions for you. Question: what if I accidentally wrote the value of 34 over here accidentally, for some reason, as 344? Would this dramatically affect the value of the mean? The average age, suddenly there was a 344-year-old individual in the group. Yes, that would definitely bring up the average age quite a bit. Got another question for you. What about the median? What if that 34 was written as 344? Would that dramatically affect the value of the median? Well, no, right? Because that 34 was not actually used in the computation of the median. No. What property is this illustrating? This example is showing how the mean is sensitive to extreme values in the data set. Meanwhile, the median is not sensitive to extreme values. What this is illustrating is a property called resistance. The median is a resistant statistic, but the mean is not resistant. I've got another question for you. Well, now that we know about this resistance property, which statistic is better, the mean or the median? Everyone's favorite answer here, it kind of depends. Particularly, it depends on the type of data. Let's look more closely. Scrolling back up for a moment, we see that if we were to rewrite by accident 34 is 344, that would really affect the mean. That would make this data set very skewed, wouldn't it, if that was a 344? So the mean would be very sensitive for skewed data, but the median not so much. So it depends on the shape of your data. Let's take a look. If you've got skewed data, now can you guess, with that 344, would that be skewed left or skewed right? Well, that would be a really large value. So that would make it that right tail very long. So this would be skewed right. That's just a little review there. So for skewed data, you probably want to use the median as some measure of center. But for bell-shaped data, classic symmetric, you can use either the mean or median. However, the mean is usually preferred. Let's look at a couple examples here to discover some relationships between the mean and median for different types of distribution shapes. Scrolling down here, we're going to look at right skewed, left skewed, and bell-shaped. Okay, I've drawn an example of each real quick there. Okay, for any data set, we know that the median is the halfway point. So for each of these, if we could somewhere find the halfway point here, such that if I was to put a tick mark somewhere, it might be right around here, that would be the location where that's the perfect balance point, where the area to the left of that vertical green mark is the same as the area to the right of it. That would be the median. And that would be the case over here too. I'm trying to find that balance point. Kind of hard to do without real numbers and a little computer to help you out. That's really easy in the bell-shaped, right? Because it's symmetric. That's going to fall right there. Okay, let's consider now the mean. The mean is sensitive to extreme values. The mean is going to be pooled by like that 344. The mean will therefore be larger than the median if the data is right skewed. So right skewed data, mean greater than median. Let's move on to left skew. Similar story, but flipped. These extreme values down here are very small and would pull the mean towards it. Imagine our ages from earlier, but then throw a baby in the room, age 2 days. That's going to bring the mean or average age down. Therefore, with a left skewed distribution, the mean will be less than the median. Can you guess what's going to happen here with the bell-shaped distribution? These are actually, the mean and median are going to align. Therefore, the mean, median, what symbol can I use to connect these two words? In theory, they would be equal, and more realistically, they would be approximately equal. There's a little bit more to the mean and median than initially meets the eye. But we've got one more M to discuss. That's the mode. See if I can squeeze this in over here. The mode is the value that appears the most. Let's look at our 7 ages from earlier. Copy paste those here. Is there any value that appears more than once? I think so. I think it's the 18. Therefore, the mode of this data set would be 18 years because it appears the most. It's not required in any way for a data set to have a mode. It's possible to have no mode in a data set, right? If these were 7 unique ages, then there would be no duplication. But you could have one mode. That's kind of like what just happened in that above example. 2 modes would be bimodal. You can have more, I suppose, but there's no requirement. On the number of modes. And that's going to sum up this video about central tendency. So some of our main highlights here were, of course, the 3 M's. That's what I call them, the 3 M's. Mean, median, mode, as ways to describe the center of a distribution. Mean, it's your classic average. Median, it's the value in the middle as long as your data is in order. And each of them is used in different contexts. However, the mean is probably more common, but it's probably also abused as well. Often popular media uses the mean to describe data sets that are inherently skewed, and so having a watchful eye is always valuable. And lastly, the mode. All right, I'll see you in the next one.